Students, today we are going to start with our semester 2 BSc Stereochemistry. Entire stereochemistry of semester 2 BSc minor paper will be covered in this video. Entire stereochemistry, yes, entire stereochemistry with all the concept, all the important things, whatever you need to know from this stereochemistry, and also important questions will be discussed in this single video, I swear. And this video is going to be approximately 2 hours. So in 2 hours we are going to complete the entire stereochemistry. I claim it to you. Let's start. So first of all, I will just show you what is this. These two are basic concept. As I said, everything will be covered, so therefore I'm saying these two structures are on the plane, and this is away from the viewer, and this is towards the viewer. So this entire molecule, these two are on the plane, this is towards the viewer, and this is away from the viewer. Okay, so if you try to make a molecule, then you know that if you take two of the things like this, then you get a molecule AB, and CD. If it is attached, a carbon can have 4 valence bonds. So over there, if I say, then you have two molecules on the plane which you can place it. One molecule which you can see coming towards you is towards the viewer, it is coming this way, and other is away from the viewer. Okay, now let us see another important thing, that is, you can write this way, that Fisher projection. Okay, we are going to do HA, HB, then we are going to see HC, HD. So in Fisher's projection you can write like this: HA, HB, HC, and HD. So this is your Fisher's projection. I'm not going to like do this over all the video because this is your first sem concept. Still I'm revising it so that when I start you all don't have any problem. Okay, so basically away from the viewer means it is above the plane. Also you can remember like this, above the plane, and this is below the plane. This way also you can remember, below the plane. So this is the concept basically which I'm trying to make you understand. You are getting it? Yes. Now let's go with your, we are going to see two Newman structures. Okay, this is one Newman structure, that is, one is the coming, another is the back of it. Okay, not any, so this is called eclipsed. This is called eclipsed Newman structure. This is eclipsed Newman structure, right? Newman eclipse structure. And this one is your staggered. Okay, staggered. This is your staggered, this is your Newman eclipsed, and this is also your Newman staggered structure. Now we are going to see what is your plane polarized light. This is an important question. This question can come in your exam also. So what is an plane polarized light? Plane polarized light. So white light consisting of electromagnetic waves. White light consisting of electromagnetic waves oscillating in an infinite number of planes at right angle to the direction of light. A plane polarized light is a light that has passed through a polarizer. Okay, passed through a polarizer. Now can you all say what is a polarizer? A polarizer blocks all the light waves except one. So what is it? A polarizer, it is blocking all the light waves except one, and the light which is producing is called plane polarized light. And white light consisting of large number of electromagnetic waves oscillating in infinite number of planes at right angles to the direction of light. Okay, so this light, when passed through a polarizer, all the wavelengths of light are blocked and only one wavelength of light comes. So that one we call it as plane polarized light. Okay, so this is your plane polarized light. So a question may come that a polarizer block all the light waves except one. So what is a polarizer? It is nothing but a filter that blocks all the light waves in all directions, light waves in all planes. Okay, it blocks all the light waves in all planes except one, and that light is coming only. See, suppose a filter is there. Now light waves are going, so this filter is blocking all the light waves, okay, except one. So this is your plane polarized light. Okay, and this all lights a large number of light waves which are rotating in the electromagnetic waves in an infinite number of planes at right angles to the direction of light. So they are coming at right angles to the direction of light. Okay, and a plane polarized light is a light that has passed through a polarizer. So a plane polarized light is passing through the filter and is plane polarized light, and these are not plane polarized light because they couldn't pass. Now what is dextro-rotatory and levorotatory? Dextro-rotatory and levorotatory. Let's see. If the direction of the plane of polarization, or if the direction of the plane polarized light, hence the rotation of the lens, hence the rotation of the lens is towards right, then we say it is dextrorotatory. Okay, we indicate it as plus sign. And if the, I'm not writing it, if the direction of the plane polarized light, or hence the rotation of the lens is towards left, and we denote it by negative sign, then it is levorotatory. This is clockwise, this is clockwise, and this is anti-clockwise. This is anti-clockwise. So this is your dextrorotatory and levorotatory. This is your dextrorotatory and this is your levorotatory. Okay. So if the direction of the plane polarized light or the rotation of the light is towards right, rotation of the lens is towards right in clockwise direction, denoted by positive, it is dextrorotatory, and this is the opposite is levorotatory, towards left. Okay. Now it is denoted by small d and small l. Okay. Do not mix with capital D and capital L. What is capital D and L? I will tell you. So by using the polarimeter, we can not only determine the direction but also the amount of rotation of the lens. And optical rotation is the number of degrees we need to rotate the lens to obtain the plane of light. Okay, so this is your optical rotation. Now we will see what is enantiomer and diastereomer. Let's see. Enantiomer is nothing but non-superimposable mirror image, and diastereomer is nothing but not mirror image of each other. Okay, so let me say you that what is polarimeter. The polarimeter not only can determine the optical activity and the direction of the uh, substance, but also the amount of rotation of the substance. And what is amount of rotation? The amount of rotation is nothing but the number of degrees we need to rotate the lens to confirm it to the light source. Okay, this amount of rotation of the plane of polarization is called your optical rotation. Okay, now we will see what are the factors that optical rotation depends on. Let's see, very important question for exam. What are the factors that optical rotation depends? So factors on which optical rotation depends. So firstly, it depends on concentration of the optically active substance. Concentration of the optically active substance. Understand it, okay? You denote it by C. So C is directly proportional to the optical rotation. Getting it? Getting it? Okay. Number 2, length of the polarimeter tube. Length of the polarimeter tube. So denoted by small l. So it is also directly proportional to the optical rotation. Okay. Next, last point you need to remember that optical rotation, I am writing by short OR. OR depends on nature of the substance, wavelength of the polarizer, temperature of the substance. Okay, now you take into consideration. If I say that optical rotation is alpha, so alpha is directly proportional, your alpha is directly proportional to C to L. Now this alpha is will introduce a constant here. What is the constant? This only. This is the constant, the C into L. This is your specific rotation. This is your concentration of the optically active substance. This is your length of the polarimeter tube. And this is your optical rotation. Now, this is your wavelength of the radiation used. We have written over here that it depends on the wavelength. So this is your wavelength of the radiation used. Now you depend on the nature. So this is a constant which depends on the nature of the substance. Depends on the nature of the substance. Okay. So clear it is. Okay, that if I'm explaining once more, because I think it got a little gingy. So optical rotation, you will write simply, it is directly proportional to C and L. Now if I say that this alpha optical rotation, we introduce a term which is specific rotation. This is the constant here, C into L. This depends on nature. This is wavelength of the light used. Okay, this is wavelength of the radiation used. This is concentration of the optically active substance, length of the polarimeter tube, and this depends on nature. Okay, so this is your optical rotation. This is your optical rotation, and this is your specific rotation. So if anybody asks you what is the formula for specific rotation, then it is C into L by optical rotation, that is alpha. This is your specific rotation. This is your specific rotation, isn't it? Yes or not? Your specific rotation is your concentration of the optically active substance, length of the polarimeter tube, and optical rotation. And your optical rotation is constant. Constant into C into L. Okay. So I have written ulta. This alpha by C into L is your specific rotation, and if I say what is your optical rotation, then it is this, then it is this. Okay, so this one is your specific rotation, alpha by C into L. Now let's see what is the definition of specific rotation. Let's do. So you can do nothing but write from this definition only, that specific rotation of a substance, of an optically active substance, can be defined as the optical rotation of a substance per unit concentration of the optically active substance and per unit length of the polarimeter tube when everything is 1 1 1. Okay, write it on your own. Specific rotation of an optically active substance can be defined as the optical rotation of the substance per unit concentration and per unit length of the polarimeter tube. Write it. So okay, now let's see some numericals on specific rotation. Okay,